Okay, so in numbers 23 through 32, we are just using the table to the right. The table to the right describes the height of a ball over time as it's thrown in the air. The height of the ball is tracked by the function h of t. If you think about it, if you're imagining throwing a ball in the air, it's going to look like this, which is a form of quadratics. You can also technically graph it, but you will have graph paper on the test, so go for it. 0, 0, 148 would be up here, 264 would be up here, 348 would be here, and then 40 would land us back here. And we would form a downward parabola. So the first question says, describe the meaning of h of 1 equals 48. Select all that apply. Remember, when it says select all that apply, we know that there's going to be more than one answer. So let's read through each multiple choice. Height 1 foot occurs at 48 seconds. So height would be the feet. Do we have any 1 for 48 seconds? No, it's actually backwards. Height 48 occurs at 1 second. Height 48 feet occurs at 1 second. We can circle B. The input of 1 second results in an output of 48 feet. Now remember, we have h of t equals this stuff. So if I am inputting a 1 for my t, what value is going to fall there? Input 1 for t, we get 48 feet. Good. And be careful, D, it kind of says the same thing, but it doesn't. The input of 48 feet results in an output of 1 foot. That doesn't make sense. So you can't have a feet into a foot. Describe the domain of h of t. So domain is all our x values. So we're imagining all integers. So that just means 0, 1, 2, 3, 4. However, be careful. Can I have 24.5 feet? We're not using integers. We're also not using all integers greater than 0 for that same reason. We're not using all integers between 0 and 4 for that same exact reason. We can have half a foot and integers aren't a half. That's all whole numbers. Positive real numbers or real numbers between 0 and 4. Now, if we look at it, we're only technically going from 0 to 4. We're not going any lower. We're not going any more to the right. So it's going to be all real numbers just between 0 and 4. We already talked about 25. It's definitely a quadratic function because of the shape of the ball flying through the air. Number 26, we don't really talk about in Algebra 1, but the function will be negative 16 t squared plus 64t. I'm going to go over how to solve it. Technically, the formula for throwing something in the air looks like this. The V stands for velocity. The C we know is the constant or the starting value. So the height it's getting thrown from. And T you know is time. So I can technically solve for that missing V. And you're going to see I already showed you the answer for V is 64. The reason there's no plus anything is because the starting value, the starting height is 0. So I can fix this equation to now say h equals negative 16t squared plus vt plus 0. I technically don't need the 0 there, but I'm going to leave it there for the first step. The variable I need is v. We can solve for v just like we solve for linear equations and everything else. I have enough information from this table to plug it in. So I'm just going to pick a point from the table. I'm just going to pick the first one, 148. I'm not going to pick 0, 0 because that's not going to help me at all. So 48 is my h. My t is 1. And then plus 0. 48 equals negative 16 plus v. I still want to get v by itself, so I'm going to add 16 to the other side. V equals 64. And that's why when I rewrite the equation, there's a v there. There's a 64 for my v. The maximum height of the ball is your vertex, which is the highest point here. That highest point was 264. So the height of the ball is at 64 feet. What's the height of the ball at the moment it's thrown? So at 0 seconds, so it's getting thrown at that point, the height is 0, so it's on the ground. Now be careful, there's 2 zeros there. Make sure you're reading the units. At 0 feet. What time does the ball hit the ground? So when the ball comes back down to the ground at 0, it was 4 seconds. And then number 30 says select all of the H of T that obtained a height of, or an output of 48 feet. So we're picking at what seconds the ball was at 48 feet, at 1 second, and at 3 seconds. What height does the ball reach at time t equals 1.2? You now have the equation right here. I am going to plug in 1.2 for t. So h of 1.2 equals negative 16 times 1.2 squared plus 64 times 1.2. So you can use your calculator. This is a calculator section. So 1.2 squared is 1.44 times negative 16 is negative 23.04, and 64 times 1.2 is 76.8. So when you add those two together, you get 53.76 feet, which is A. The last one says select the following that are true statements. They want to know if h of 1 is greater than h of 2, and so forth all the way along. So if I look up top, h of 1 is 48, and h of 2 is 64. So 48, is that greater than 64? No, so that's not one of the answers. H of 0.5, there is no 0.5 here, but if you want to round, it's about 24 because it's halfway between 0 and 1. I'm going to put 24 down here. And then 3.5 would be around here. So 48 halfway there would be about 24 feet. 24 does not equal 24, or is not greater than 24, so I can cross that off. The next one, h of 1.5, falls between 48 and 64, which halfway between the two would be 56. And then 3.5, again, is another 24. And 56 is greater than 24, so I can circle that one. H of 1 is 48. And then 2.5 again is 56. Is 48 greater than 56? No, so our only answer there is C. So those are your homework problems 23 through 32.